Alright, y'all, last video of section 7.2, we're talking about writing systems of equations. And our first example here, y'all can read it. Actually, I'll read it too. So this is the break-even analysis. A shoe company invests $300,000 in equipment to produce a new line of athletic footwear. Each pair of shoes costs $5 to produce and is sold for $60. How many pairs of shoes must be sold before the business breaks even? So something to note very first, before we start this problem, is what it means to break even. So that's when revenue equals cost. So that kind of gives us a big hint on what we're going to do with the equations once we find them. But we'll show you that in just a second. So we're going to find equations for both the cost and the revenue, seeing how that's the things we're trying to find to break even. The cost is going to be simply what they invested. So what did they invest? $300,000. And we'll do C for cost. And then the revenue is going to be how much each pair of shoes costs to buy minus how much it costs to make, if that makes sense. So it's the net profits of the shoe, basically. So it will, or they will sell for 60 each, and I'll do each for X, or I'll do X for each shoe bought. And each time a shoe is bought for $60, there was $5 spent on it in production. So it'll be 60x minus 5x equals the revenue, and we'll use R for that. And this is going to be our system of equations. And so to solve this, we already have one of the variables isolated, and that's going to be C. But that doesn't really do anything for us, right? So I don't think we're going to be using substitution. But let's look back at the problem and think about what breaking even means. Breaking even is when revenue equals the cost. And what do we have here? We have our revenue and our cost. So what we're going to do in a situation like this is just set them equal to each other. So we have 300,000 equals 60x minus 5x. And to solve that very simply, we will just combine like terms over here. Wow, that is an ugly 5. 300,000 equals 55x. Divide both sides by 55, and we'll see that x equals did that in my head. And what does x represent? It represents that, or it represents the amount of shoes it would take for the company to break even. So it would take 5,455 shoes for the company to break even on their investment of this equipment. And so next, we're going to talk about an airplane. And so I'll read this one again. Linear systems. An airplane flying into a headwind travels the 2,000-mile flying distance between Chicopee, Massachusetts, and Salt Lake City, Utah in 4 hours and 24 minutes. On the return flight, the same distance is traveled in 4 hours. Find the true airspeed of the plane, comma, the speed of the wind, comma, assuming that both remain constant. And if I said that word wrong, please make fun of me in class. So something that we got to keep in mind, we will think about things that we know already. We know we're dealing with distance, and we have time, and it looks like we're trying to find the rate. And so this reminds me of our distance formula, which is d equals two lower cases, RT. And so that's what we're going to use. So let's think about in both these equations what our distance is. Our distance is going to be 2,000 in both cases. But on the way there, we know that we make it there in 4 hours and 24 minutes. So that's our time. and 4 hours and 24 minutes represented in seconds, like in terms of time. We can do 4 and 24 over 60. From there, we got to find the rate we're going, and so we need to find the speed of the plane and the speed of the headwind that's pushing us in the same direction. Does that make sense? So we are a plane flying into a headwind for 2,000 miles, and so the plane is going to be, or the wind is going to be pushing against us, so that's going to be a negative wind per se. And then when we're going back, the wind is going to be pushing us forward, making it a positive wind. And so this is where I'm thinking we're going to take the plane speed, and we'll go with P for the plane speed, and our speed on the way there is going to be our speed minus the speed of the wind, and then our speed on the way back is going to be the plane speed plus the speed of the wind, because it's coming from our back, pushing us forward. Okay, so let's think about these. Let's keep these in mind. And so in relation to these, for the second one, we know that we traveled it in 4 hours flat. So we'll write that here too. But like we saw here, on our way there, which is this one, we know that our speed can be represented by our plane speed minus the wind speed. And then similarly for the second equation, we know it can be represented by the plane speed plus the wind speed. So from here, we got two equations that we know how to solve. It might look a little funky at first, but if you use the methods of elimination, we can scale these down, which is what we're going to do. So we'll divide this whole thing, which is essentially the same as multiplying by a fraction, so we can divide or multiply. We'll divide it by this factor right here. And then for the bottom one, we will multiply it by 1/4, so that would be the same thing as divided by 4. And then from there, our new system looks like this. And now this is definitely a system of equations that we are capable of solving. We can add these together because this is an elimination. We'll eliminate the W, and we'll get 2P equals, what is it, 954.55. And so P itself equals 477.23. And so P, since it represents the speed of the plane, we can say that P equals 477.23 means that the plane was traveling at 477.23 miles per hour. So I'll put the MPH right here. And then we'll plug that back into the original, one of the original equations right here. Or we can just do it in this equation because these are the same things, just scaled differently. So we'll do 477.23 plus W equals 500, and we'll see that W equals 22.77, which is also miles per hour. So the wind speed was 22.77 miles per hour, and the plane speed was 477.23 miles per hour. That's all we got for this module. That's all we got for this video. I'll see y'all in class. And if y'all got any questions on this, just like I've said with the last videos, we'll definitely go over it.